All right, I'm back. I'm on page 246. I'm going to try to do A, B, and C here. And I'm going to do them as if you could pause, rewind, and watch again if you needed to. So I'm going to go like a little quickly, but that's okay. So I need to go from -1 to 4 at -1 to 4. So one of the secrets of this is like you don't really care what the y value is. Like this is a thing that has a positive slope. So I'm going to say it's here and here. Is this an accurate drawing? Whatever. So this is my region. It's a trapezoid. I could actually just find the area if I wanted to, like 1/2 the height times the sum of the bases, like that would do it. But we are doing our rectangle sums, which are actually called Riemann sums if you want to look it up. I don't remember how to spell that. Riemann. They're named after Bernhard Riemann, who has a very cool name. Did a lot of like challenging math stuff. There's the Riemann hypothesis is one of the great unproven theorems, not theorems, I guess, conjectures in all of math. So look that one up. It's about the distribution of the primes. Solve that, and we're gonna have a lot of trouble with our credit card security, basically. All right, so delta x is going to be 4 minus -1 over n, 5 over n. X of I is going to be -1 plus I delta x. And then our summation, so A as a function of n, I almost put a v there. The sum from I equals 1 to n of, so it's going to be f, let's call this f of x. So like you shouldn't use f of x unless it's named that. And the function was initially called y, so I've renamed it f of x so that I can write f of x sub I. That's the height times the base. All right, let's jump to the calculator and see what we get. So remember, you can pause this, you can rewind this, you can definitely not complain about the pace of this. Let's see, so new problem, f of x is 3 plus x over 5. And then I want to do a of n is the sum. You're crazy if you don't use the template here. The sum from I equals 1 to n of f of x of I is -1 plus 5i over n times, so that's the height times the base, which is 5 over n. And I'll press enter and do a of 1000 because that's what it's asking for. Okay, so I get that. If I wanted to do this as a trapezoid, I can do f of -1. That's the first base, I guess. F of 4, that's the second base. So I want to do 1/2. The height of this thing is 5. And then I need the sum of the bases. So 14 over 5 plus 19 over 5. So it seems like this isn't going to work out nicely, but it probably will. So I get 33 over 2, which is 16.5. My approximation, 16.503, pretty good. So if you're not sure what I did, go back to the picture and find f of -1, find f of 4, and just find the area of that trapezoid, because that's what I did there. So I'm going to go back, fill that in. I don't know why I don't fill it in before. 16 point, see, I should have done it. I can't remember that number. Okay, so a of 1000 was approximately 16 point, I think it was 025. I wish 16.5025, so 503. All right, so now, and then we found the exact value was 16.5, so that's pretty good. All right, this next one. We're not given bounds or anything, so I'm thinking we're gonna go x-intercept to x-intercept. So let's see what this looks like. I'm gonna start off, I'm gonna factor this thing. I'm actually gonna make it negative quantity x squared minus x minus 6. I hate negative leading coefficients. They're like, makes it so much harder to factor. X minus 3, x plus 2. All right, let's, I don't know if you can hear my stomach there, but I am hungry. Also, that would be crazy if you could hear that. I hope the mic did not pick that up. -2. So we got -2, and we have 3. That's definitely to scale. And it's quadratic that opens down, so something like that. Barely got it. All right, we're good. Find our delta x. It's going to be 3 minus negative 2 over n, so 5 over n, which I think is the same. That's weird when I like make up random problems and that happens. X sub I is going to be negative 2 plus I delta x, so 5I over n. All right, so then we're going to write an area function, a function of n. The area is a function of n, so the sum from 1 to n of the height, which is f of x sub I, times the base, which is delta x. All right, so we got that. Now, calculator time. Remember, you can pause this, you can rewind this. Just trying to get these three in so that I can get to the next one, which is the more interesting of them. The most, I guess I should say. New problem. You can have like a lot of problems in your calculator page. The more problems that you have, eventually it actually slows down your calculator. So like new document every once in a while, but like, you know, it's safe. So f of x, oh, I'm realizing I did not define f of x, was negative x squared plus x plus 6. All right, so if you needed to, you could do solve f of x equals 0 for x, get those values. That's if you needed to. A is a function of n. So this is a weird area. Like this is our only option. We would not be able to do this using other techniques that we're aware of. I goes from 1 to n. So the height is going to be f of x sub I, which is negative 2 plus 5i over n times the base. So height times base. Tell yourself that, height times base. 5 over n. A of 1,000, I get 20.833. Let's find the limit and see what it is. I mean, that seems like it's, what does that seem? What's 8.83? I don't actually know what that fraction is. Let's do a limit just while we're here. Limit n to infinity of a of n. Ooh, look at the accuracy on that, right? So 1,000 rectangles versus an infinite number, same to 4 decimal places. Very cool. So I'm going to write this down so that when I get back to the notes, I don't have to wonder. A of 1,000 is I'm going to put approximately because it is an approximation, even though we have found that it's the same. 0.833. I just had a second there where I was like, oh no, I'm not projecting the iPad, but I'm not projecting the iPad. Okay, so back to the iPad. This whole thing's like a giant commercial for iPads. What am I using? I'm using Notability on my iPad. I like it. I tried GoodNotes. It's also good, you know, as per the name. I don't know that I recommend this, I guess, because I'm using it, but like they're basically the same. All right, y equals sine of pi x over 4 and the x-axis from 0 to 4. All right, start with a picture. Do you really need the picture? No, you don't. You don't really need the picture, but this is, so the period of this thing is 2 pi over 4. So the period's 8. I was not anticipating that. Why do I always do that? I always do like half of these. One wonders. Oh, I know why, because it's going to be like the top hill, right? So we're going to go like here, here, here. So this is what we're interested in. Just the area of that thing. Okay, so I need a delta x is going to be 4 minus 0 over n, so 4 over n. X sub I is going to be 0 plus 4i over n. And then our area as a function of n is going to be the sum. Woo, terrible. I struggle with those. And if you end up having me later in math, you'll find in Calc 2, like Calc CD type stuff, you got to write them all the time. And I just like have never gotten good at it. Like if it was going to happen, it would have happened. All right, so I got to name this f of x. And actually, I'm going to go back because I feel bad about the other one. I'm going to name this f of x too. Oh, it did. Look at me. I'm a champ. No, wait, wrong problem. Ah, look at me. I'm a chump. All right. Equals f of x. There. So you can just use it. Proper notation. So it matters. It's important. So the height is f of x sub I, and then the base is delta x. To the calculator. It's like the old Batman. To the Batcave, to the calculator. Here we go. I'm going to put in a new problem. Doc for 1. F of x is... Like, I made a lot of videos today. This is actually going to be my last one for today. Like, you'll know because my shirt will probably be different in the next one. And if it's not, it's probably because I screwed up. Here, and then area as a function of n. So this one, the calculator will not be able to take the limit because of the trig function. It doesn't know summation formulas for trig functions. It knows them for polynomials, not for trig stuff. So we're not going to be able to get the exact value out of this, but that's okay, because 1,000 rectangles is a lot of rectangles. And we could probably try 5,000 too. Let's go from 1 to n of, f of, what am I doing? 4 times I over n, right? So that's our height. I'm not going to square that. What am I even doing? So like as soon as I started to think about stopping for the day, suddenly like all heck breaks loose. Okay, a of 1,000. Okay, what's a of 5,000? Ooh, look at that. So 1,000, pretty, what's a of like 100? So this thing zeroes in on 3 decimal places very fast. Think about the rectangles that you're making. Until you get to 2, the rectangles are always over approximations, which I'm like trying to draw. Once you get past 2, all of your rectangles are underestimating. So it's like they're balancing themselves out a little bit. So that's why we're getting like so accurate so fast. So I'm going to write down that a of 1,000 is approximately 2.546. 2.546. I'll go back to the notes so you can see that. And then I think I'm going to stop for today. But as I mentioned, not really relevant to you. Here we go. This is what it looked like. And I will be back in the next video, potentially in a different shirt. And I will do part D, which is going to be a little bit different. So I hope you found this helpful. If it went too fast, go back, watch it again, slow it down. You can hit the gear and just watch it at like 0.75 speed or something. Anyway, I will see you next time.